This slide and the next slide explain how to define and insert into a named window. The type definition for a named window has two forms. The first form provides an event type name, and the second form lists property names and types. Named windows always start empty, and named windows always define a data window. The first form, which we discuss on this slide, provides the event type name of an existing event type. The syntax is create window ... as event type name. The event type name defines the event type of events held by the named window. Note, this does not populate the named window, it only defines the event type. For instance, the EPL that defines a named window that holds the last 10 seconds of large withdrawal events is create window large withdrawals at time (10) as withdrawal. The insert into, for this example, is a select star, like so. Insert into large withdrawals. Select star from withdrawal. Parenthesis amount greater 400. This page describes the second form of defining a named window. The second form of defining a named window provides property names and types. The syntax is create window ... as parenthesis, property name property type, comma property name property type, and so on. The example defines a named window to hold the last 10 seconds of events wherein each event has an account ID and a threshold property. Create window account thresholds at time (10) as parenthesis, account ID string, comma threshold double. The insert into typically has expressions that provide some or all properties. The compiler validates expressions, property names and types and performs widening when required. To illustrate, the EPL that inserts events is insert into account thresholds. Select account ID, compute threshold (W) as threshold. From withdrawal as W. This example assumes that there is a compute threshold function defined, not shown, and that takes a withdrawal event as a parameter and returns double. Defining a table is the subject of this slide and the next slides. A table can have a primary key, which may consist of a single or of multiple columns. Use the primary key keyword for columns that make up the primary key. If there is no primary key column, the table can hold only 0 or 1 row. When multiple columns have the primary key keyword, a combination of more than one column identifies the particular row in the table, also known as composite key. The runtime supports any object type for primary keys including arrays. Let's say we need to define a table where the combination of account ID and order ID uniquely identifies each row. Create table account order table parenthesis, account ID string primary key, comma order ID string primary key. The runtime enforces the unique key and does not allow rows that have the same primary key, here, same account ID and same order ID. Tables can have aggregation-typed columns that hold aggregation state. Tables allow aggregation state to stay in a central place for shared read/update/reset. Tables allow any number of columns and aggregation functions including those holding events or more complex state. When the column holds aggregation state, provide the type of the aggregated values, i.e. some int. A sample table keyed by account ID with an amount per account sum of integer type column is create table ACCT totals table parenthesis, account ID string primary key, comma amount per ACCT sum parenthesis int. This example defines an unkeyed table with an overall count type column. Create table overall count table parenthesis. Overall, count. Count parenthesis star. There is a special into table clause. The into table is only for use with tables. The into table clause aggregates into table columns. Into table is specific to EPL and standard SQL does not have this clause. When using into table, the respective aggregation state lives in the table column, or table columns if there are multiple. Multiple EPL statements can aggregate into the same or other table columns. The into table clause requires the following. The group by clause must match the table's primary key columns in number, order and return type. Aggregation expressions must be in the select clause and must be named matching the table column names. Each aggregation type must match the aggregation type of the table column. The compiler validates these preconditions. The into table clause does not delete rows. Let's say we want to keep an overall count and total. The example create table and into table is create table overall total table parenthesis. Overall count star. Comma overall amount sum parenthesis double. Into table overall total table. Select count star as overall count. Comma sum parenthesis amount is overall amount. From withdrawal. The table has no primary key, thus the table always has either 0 or 1 row. The table has no primary key, therefore the into table statement does not allow a group by clause. The table column names and the select clause names must match. Here the table column names are overall count and overall amount. The aggregation types must match. Here, the aggregation types are count star and sum of double. The runtime allocates a table row when the first withdrawal event comes in. The table makes the current count and total available to other EPL statements, see later examples. And fire and forget queries. This example table holds totals per account. Create table account totals table parenthesis. Account ID string primary key. Comma total sum parenthesis double. Into table account totals, table. Select account ID. Comma sum parenthesis amount is total. From withdrawal. Group by account ID. The table has account ID as the primary key, thus the table rows are unique by account ID. The table has account ID as the primary key, therefore the into table statement's group by clause must also have a key, here, account ID. The table column name and the select clause name must match. Here, there is only a single column by name total. The aggregation type must match. Here, there is only a single aggregation which is sum of double. The runtime allocates table rows as withdrawal events with a new account ID come in. The next couple of slides discuss selecting from a named window in table. First we discuss selecting from a named window. A named window pushes insert and remove stream events. Thus, other EPL statements get continuously updated, by receiving the differences that occur. So the runtime only tells statements what changed, and statements themselves can update their own aggregations or other state. The runtime pushes new events, that are inserted into a named window, as an insert stream to other EPL statements. Insert can be because of insert into, on merge, on insert, or fire and forget insert. The runtime pushes old events, that are removed from a named window, as a remove stream to other EPL statements. Removal can be because the data window removed the event, for example, when declaring a time window. Removal can be because of an on merge, on delete or fire and forget delete. Both insert and remove can be because of an on-update or fire and forget update. The runtime pushes the insert and remove stream to any statement that has the named window in the from clause. This slide continues the topic of selecting from a named window and provides a detailed example. Consider the EPL as shown here. First, the EPL defines a named window that keeps the last 10 seconds of withdrawal events. Create window withdrawal, last 10 sec. At time parenthesis 10. As withdrawal. The next statement inserts all arriving withdrawal events into the named window. Insert into withdrawal last 10 sec, select star from withdrawal. The next statement selects the count and total amount, per account. Add name parenthesis quote totals per account. Select account I, comma count star, comma average parenthesis amount. From withdrawal, last 10 sec. Group by account ID. Another statement selects the overall count and average amount. Add name parenthesis quote totals. Select count star, comma average parenthesis amount from withdrawal, last 10 sec. When a withdrawal event arrives, the steps that take place are: the runtime inserts the event into the named window, and the runtime pushes the new event, as insert stream, to the totals per account and the total statement, which both update aggregations and produce output. When a withdrawal event gets older than 10 seconds, the steps that take place are: the runtime removes the event from the named window, and the runtime pushes the old event, as remove stream, to the totals per account and the total statement, which both update aggregations and produce output. Filter expressions can be applied in the from clause after the named window name. This example selects a count of the last 10 seconds of withdrawals with an amount greater 400. Select count star. From withdrawal, last 10 sec. Parenthesis amount greater 400. The compiler validates according to the event type of the named window. For instance, the expression account ID greater 100 will not compile, as the account ID field was declared as a string type. One cannot compare a string and a number with a relational operator. The selecting statement cannot have the named window and another data window. For instance, the data window, at time parenthesis 30 seconds, will not compile, as the time window is not allowed here. Since withdrawal last 10 sec is a named window, and already specifies a data window, the compiler does not allow another data window. This slide is about selecting from a table. A table does not push an insert and remove stream. A table therefore typically appears in joins, subqueries and table access expressions, discuss later. Fire and forget queries. Or iterated using the programming interface's iterator. This example defines a table and selects from the table. The statement that defines the table is named table define. The statement that selects from the table is named table select. There is no output to listeners for both table define and table select statements. An application can use the statement safe iterator method to iterate. Or the table can be in a join, subquery, etc. This slide discusses joining a named window. A named window pushes insert and remove stream events. In a join, both insert and remove events can trigger the join. The runtime updates indexes from insert and remove stream events. For instance, define a window to hold the last 10 seconds of deposits. Create window deposit window. At time parenthesis 10. As parenthesis. Account ID string. Comma amount big decimal. The statement joins the last 10 seconds of withdrawals to the last 10 seconds of deposits. Select IR stream star. From deposit window as D, withdrawal. At time parenthesis 10 as W. Where D.account ID equals W.account ID. This join produces output when inserting or removing a deposit window event, or when a withdrawal event arrives or leaves the data window. The compiler allocates implicit indexes for account ID for fast lookup. Both insert and remove streams add and remove events to and from indexes. A named window can join to itself. The example creates a window to hold page hit events for the last 10 seconds. The join selects page hits for the same user where the URL matches the value some URL. Select IR stream star. From page hit window as W1 unidirectional, page hit window as W2, where W1.user_ID equals W2.user_ID, and W2.URL equals some URL. This join has the unidirectional keyword, so the join only triggers when a W1 event is inserted or removed. The runtime builds and maintains indexes for user ID and the combination of user ID and URL. When joining with a table, tables in the from clause are passive, i.e. don't cause the join to trigger. For instance, select star. From settlement event as SE, account totals table as ATT, where SE.account ID equals ATT.account ID. Only when a settlement event arrives does the join trigger. Subqueries can be applied to named windows and tables. Subqueries in general are discussed later. Subqueries are often used with named windows and tables. Place the named window name or table name into the from clause of the subquery. For named windows, add filter expressions as needed. This EPL is an example. When a login event arrives, it outputs the user ID and the count of events in page hit window that have a URL of some URL and the same user ID. Select user id, parenthesis. Select count star. From page hit window, parenthesis URL equals some URL. As MW, where MW.userID equals LE.userID. As page hit count. From login event as LE. When a page hit window event gets inserted, the runtime checks the URL and updates account per user ID. When a login event arrives, the runtime returns the count for that user. The subject of this slide is table access expressions. Table access expressions read from a table. Like subqueries, table access expressions can be used in expressions in all clauses. Table access expressions can only be used with tables. The syntax for tables without a primary key is table name dot value expression. The syntax for tables with primary key columns is table name brackets key expression comma key expression and so on dot value expression. Provide the same number and return type for key expressions as the table defines primary key columns, and in the same order. The value expression is a column name, and optionally a dot expression for objects or for aggregation state that has accessor methods. See documentation for more information. Table access expressions return null if the row does not exist. Let's look at some examples for table access expressions. Like this EPL, which reads from a table without primary keys. The example first defines an unkeyed table to hold the overall count. Create table overall, count, table. Parenthesis overall count star. The next statement outputs the current count when a transfer event arrives. Select overall count table.overall count as the count from transfer event. And the sample EPL that reads from a table with a single primary key column is. The example defines a table keyed by account ID to keep a total amount per account as a sum of double. Create table account totals, table. Parenthesis account ID string primary key. Comma amount per account sum parenthesis double. The next statement selects the account's amount, with the account ID provided by the transfer account ID property of the transfer event. Select account totals, table. Brackets. Transfer account ID. Dot amount per account as AMT. From transfer event. The compiler validates the number and return type of key expressions against the table's primary key columns. In the last example, the compiler validates that the transfer account ID property of the transfer event has the same type as the account ID primary key of the table.